All right, this is Sensation and Perception, Section C lecture. Our prioritized standards this time is 5C, D, and E. Objectively, we're going to evaluate the process of perception. Now, the task of perception is to extract sensory input from the environment and organize it into stable and meaningful percepts, which are meaningful products of perception going beyond just mere sensation. A percept is often thought of as an image that has been associated with concepts, memories of events, and also motives. Now, while perception produces an interpretation of the world, it does not actually produce a perfect representation of it, as we'll find out a lot of things in this unit. Now, physical and mental processes are involved in forming perceptions. Now, there are cells in the brain that specialize in extracting certain features of a stimulus known as feature detectors. Now, feature detectors combine or bind the sensations of color, shape, boundary, and texture to produce the percept of a person's face. How the feature detectors are capable of creating unique percepts of things is one of the major unsolved mysteries in all of psychology, which is sometimes referred to as the binding problem. So, for instance, we see potentially different things, but there's a lot of different things that come into play before we can actually recognize what it is we're looking at. Again, these different types of feature detectors. How we do that, nobody really knows how we do that, but we do know that it happens. Now, perception of sensations can be analyzed in one of two ways, or two types of processes. You can have bottom-up processing or top-down processing. Now, bottom-up processing, this is perceptual analysis emphasizing characteristics of stimuli. So it's going to be a more data-driven process that focuses on incoming data and takes place in real time. So essentially with bottom-up processing, you're trying to determine, what am I seeing? Now, with top-down processing, this is perceptual analysis emphasizing the perceiver's expectations, memories, and other cognitive factors. So information is interpreted using contextual clues and uses previous experiences and expectations. So like trying to understand sloppy handwriting based on what we know about what handwriting is supposed to look like. So top-down processing is more like, is that something I've seen before? Now, an important aspect of perception is perceptual constancy, which is the ability to recognize the same object as remaining constant under different conditions. So this can include size constancy, shape constancy, and color constancy. Perceptual constancy helps individuals identify and track objects with a changing type of environment. So size constancy, here's an example here. This is the tendency to interpret an object as always being the same actual size regardless of its distance. So if you got out a ruler, this is longer than this, but our mind perceives that, oh yeah, these are basically the same size, it's just at different points. So that's what is meant by size constancy. Now, shape constancy, this is the tendency to interpret the shape of an object as being constant, even when its shape actually changes on the retina. So, for instance, we can tell this is the same even when we see it in different shapes and different angles. Now, color constancy is the tendency to perceive the apparent color or brightness of an object as being constant, even in different types of lighting. So, for instance, what color are those strawberries? Chances are you're thinking red, but they're not red. These are red strawberries. If we actually look at the color of these, that's what the color is of those strawberries. But our mind tells us that strawberries are red, so these are red, even though they objectively are not red when you actually look at them objectively. Now, while the primary goal of perception is to get an accurate interpretation of the world, sometimes our perceptions can be wildly inaccurate because stimuli are misinterpreted in what are known as a perceptual illusion. So you're going to find out through this that a lot of your mind makes guesses, and sometimes those guesses are wrong. So perceptual illusions often arise due to a stimulus containing misleading cues that can give rise to inaccurate or impossible perceptions. So, for instance, where's the top of the stairs here? Is it here? No. Is it here? 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 So again, it's impossible. It's not accurate. Now, perceptual illusions are more likely when the stimulus is unclear, when information is missing, when elements are combined in unusual ways, or when familiar patterns are not actually apparent. All right, so when you look at this picture, are you seeing an old lady or are you seeing a young lady? Now, depending on which one you are seeing, you're going to think, what is he talking about? Well, if you're looking at an old lady, here's the old lady's nose, here's her eye, there's her other eye, there's her mouth. She's got hair here, looks like she's got some sort of hat on over that. If you're looking at a young lady, it looks more like she's looking off her side, looking behind herself, and here's her ear, and there's her chin, and she's wearing a necklace and some sort of hat. So again, which one's right? Well, it all has to do with your perception. Now, to study illusions at the level of perception, psychologists may employ ambiguous figures, which are images that are capable of more than one interpretation with no right way to see it. So ambiguous figures can actually suggest two conflicting meanings that your perception will cycle back and forth between as you look at a figure. So here's a Necker cube example. So where's the top of this? Is this the top of it? Or is this the top of it? So which is right? There really is no right or wrong way to look at that. But once you have noticed it, you can probably see it and you'll actually cycle back and forth between the different images. Now, to make sense of illusions, people draw on personal experiences, learning, and motivation, yet people can use knowledge of illusions actually to their benefit. So, do you think that's moving? It's like if you concentrate and look at any of these are not moving at all. But possibly your peripheral vision will make it look like it's moving until you focus on the movement. Once you focus on the movement, it's not moving. But your mind will tell you that it's moving even when it's not. Now, architects and interior designers actually create illusions that make spaces seem larger or smaller than they really are. For instance, you might want to make a small apartment look more spacious when it's painted, using things like light colors, being more sparsely furnished, or thrown in a nice mirror here and there gives the illusion that this room is a much larger room than it actually is. Now, people often make use of illusion in choices of clothing and cosmetics, like how dark colored clothing usually makes a body look slimmer. So this is the same person, one with a white shirt on, one with a black shirt on. The black just naturally looks more slimming. And also the use of vertical stripes usually makes the body look slimmer also. So the horizontal stripes kind of makes you look wider. Vertical stripes makes you look skinnier. It's just one of those things. Now, Gestalt psychology emphasizes that perception in the human brain innately organizes stimuli into meaningful perceptual patterns, which led to the Gestalt principles of perception that detail how brains create structure by default. So it is actually suggested that these principles or laws are at play in structuring human visual perception. So again, Gestalt is going to suggest that these are naturally occurring in all humans. So for instance, they point out the figure and ground principle that states that people instinctively perceive objects as either being in the foreground or in the background. So a figure is going to be a part of a pattern that commands attention and stands out against the ground. As where the ground is a part of a pattern that does not command attention and is perceived as the background. So this is another kind of ambiguous figure that we're going to be looking at here. So like, is this a vase? So if you see a vase, then this is your figure, and then the white around it is the ground. But if instead you are perceiving this as two faces looking at each other, then this becomes the figure, and then the black section becomes the ground. Now, the closure principle states that when looking at a complex arrangement of visual elements, we tend to look for a single recognizable pattern. So when divisions occur, people perceive subjective contours, which are boundaries that exist not in the stimulus, but only in the subjective experience of your mind. So closure makes you see incomplete figures as wholes by supplying the missing segments or filling in the blanks and making inferences about the potentially hidden object. So how many triangles do you see here? So a lot of people are going to say, I see two. You got this triangle, you have this triangle. But objectively, you see 0 triangles because none of these are connected. So there are no triangles, but your mind is telling you, well, there's one triangle over here, and there's one triangle that happens to be behind it. The similarity principle states that when things appear to be, or things that, let me start again. The similarity principle, states that when things appear to be similar to each other, they are grouped together. So if there are similarities of color, size, orientation, texture, type front, boxes compared to circles, our mind is basically going to tell us that these boxes have something in common with each other, and these circles have something in common with each other, even if they don't. That's just kind of the nature of the human mind. There's also the proximity principle. So this states that things that are close together appear to be more related than things that are spaced apart. So these are closer together, so we are assuming that these are related to each other. But if they were not spaced apart, we don't really think that there's any more relation to them than anything else. The continuity principle, this states that elements that are arranged on a line or a curve are perceived to be more related than elements that are not on a line or a curve. So we are perceiving that these are somehow supposed to be connected by looking at them. Even if they're not connected, our brain's going to make that connection anyway. We also have the common fate principle that states that we tend to group similar objects together that share a common motion or a destination. So we are assuming that, oh, they're all going in this direction. That's, again, another thing the mind does. We also have the simplicity principle. Sometimes it's called the Pragnaz or the good figure principle. This states that the simplest organization requiring the least cognitive effort will emerge as the figure. So, for instance, when we look at this, the least effort is to assume that we have 5 interlocking circles. Even if that's not what it's intended, that is what we just assume because it's the easiest thing. It's the most simple thing. Now, the symmetry principle, this states that elements that are symmetrical to each other tend to be perceived as a unified group. So again, these are symmetricals. We assume these are together. We assume these are together. We assume these are together. Now, depth perception is the ability to perceive the world in 3 dimensions. Information taken in by both eyes, aiding in depth perception, is going to be known as binocular cues, which we're going to talk about first, which include binocular convergence and retinal disparity. Now, binocular convergence refers to the amount of rotation our eyes have to do in order to focus on an object. So, your eyes have to rotate more for items that are going to be closer together. So if somebody wants to show you something right in your face, then your eyes are going to kind of turn into each other to try to read that. So they rotate more for things that are closer. And if it's further away, they actually will rotate less so that you can actually focus on them. So this can help people determine if things are near or far away. Now, retinal disparity. This refers to the fact that our eyes see the world from a slightly different angle. So there's a greater difference in the images, the 2 different images in our eyes, when things are very close. than when things are further away. So there's a greater distance in the image of the eyes with closer objects than with distant objects. So you're going to see two conflicting more so than if something's further away. So this difference in images is triangulated by the brain to figure out what the correct distance of it happens to be. So we don't actually think much about that. Now, information about depth that relies on the input of just one eye is known as monocular cues, which include relative size, interposition, atmospheric perspective, shading and lighting, and motion parallax. No particular order. Relative size, this refers to the fact that the more distant an object, the smaller it will appear. So these beetles look a lot larger than the cars, or the people that are way down there, or the people over here. So it just gives us that impression. So that's how we can determine what's close and what's far away. Another monocular hue is shading and lighting. So this refers to near objects appearing brighter and more colorful, while further objects appear to be darker and less colorful. So these look lighter, so these look like they are much closer to us than these that are darkened. Interposition, this refers to when there are overlapping objects that this basically tells us that the overlapped object is considered further away. So this overlaps this, so this is closer. This one overlaps that, so this one's closer. This one slightly overlaps that one, so that one's closer. Now, motion parallax, this refers to the perception of motion, where close objects appear to move more quickly than objects further away. So, for instance, if you look at this one is moving at a slower rate than everything else that is supposed to be closer. So the closer things zip right by, but these that are further off in the distance seem to stick around much longer, as for instance. Atmospheric perspective, this refers to the haziness surrounding objects that are further away, causing distance to be perceived as greater. Sometimes they call this aerial perspective, but this is also another common thing our eyes will do for depth perception purposes. I'm going to ruin this name. Psychologist Hermann von Helmholtz, his theory of perception, way back in 1866, is known as learning-based inference, which believes that perception is primarily shaped by learning or experience rather than by innate factors. So learning-based inference suggests various experiences lead people to make inferences or guesses or predictions about what sensations mean. So, for instance, people might infer that lighted candles on a cake mean, hey, there's a birthday party that's going to be taking place. Even if there isn't a birthday party, our experiences tell us this is what this image means, as a for instance. Now, perceptual inferences are hypotheses about our sensations, and while often accurate, sometimes these hypotheses prove incorrect, leading to perceptual illusions or potentially erroneous conclusions. So, like if you did this activity, speak the color, not the words. So you're probably going to find that your brain's going to have a hard time yelling out green, yellow, red, because it doesn't match. Also, if you looked at this and you had to try to determine, okay, which of these orange circles is bigger, your brain's going to make a prediction. Might not always be accurate. If you're curious, these are the exact same size. Get out a ruler and measure them, they're the exact same size. Now, people learn to expect people or objects to have certain features and fixed arrangements, so even when presented with conflicting stimuli, the brain can have difficulty recognizing it. Now, hey, it's Britney Spears. She looks a little bit different. Wonder what she looks like if we flip this upside down. She looks like that. So I'm guessing this is a picture on the right is much more different than you were expecting it to be based on having looked at this one. Now, once you identify context, you actually form expectations about what persons, objects, and events you are likely to experience. So people sometimes have difficulty recognizing people they know in situations where they don't actually expect to see them. So, for instance, you saw this lady at the grocery store, but if you saw her in this instance with her husband, you'd be like, "Oh, that's Kate Middleton. She's married to someone that's in line to be the king of England." Or like if you saw Mr. Booth out and about without a tie on, just on the weekend, you might have difficulty recognizing that, hey, isn't he supposed to be locked up in school? That doesn't look right. Now, context is a useful cue in identifying ambiguous stimuli. So, like if you're trying to recognize objects in a dimly lit room, as a for instance, or possibly if you're trying to decipher hard to read handwriting. Now, another way learning impacts perception is in what is known as a perceptual set, which is a tendency to perceive or notice some aspects of the available sensory data and at the same time ignore others. So is that the Loch Ness Monster? Or is it a tree branch? So if you look at all the surrounding things around it, you might be like, it's a tree branch, as opposed to Loch Ness Monster. Now, a perceptual set involves a focused alertness for a particular stimulus in a given context. So when the sound of someone at your front door during the day, that's not going to elicit the exact same response as if you heard a sound of someone at your front door if it was in the middle of the night. So depending on the context, that's going to lead you to have different type of reaction. Now, a perceptual set is influenced by factors like expectations, emotion, motivation, and culture. So what is this? Is this a 13 or is this a B? So again, kind of depending on the other factors around it, this is going to tell us if we perceive this as being a B or if we perceive this as being a 13. Now, cultural experiences can actually have been proven to have an influence on some people being able to see certain illusions. So, for instance, this Ponzo illusion, this is more commonly experienced by people from mainland United States than from people that might live in other places like Guam, where visuals like this might not happen. So, which red line's longer? They're actually the same. They're the same. So they look different, but they're not actually any different. They're the same. So again, in our culture, we're likely to notice this. Other cultures, they don't notice this. Now, attention is a key component of both sensation and perception. Without attention, perception is not possible, and things become just light and noise. So when someone is talking to you, but you're not actually paying attention to them, all of the stimuli are going to be at work basically for nothing. All right, that concludes Sensation and Perception, Section C lecture. Our prioritized standards again were 5C, D, and E, and objectively now I can evaluate the process of perception.